Hello students, welcome back. In the last two videos, I had explained you about polar coordinates and angle between the radius vector and tangent to the polar curve, and I also took few problems on the concept, based on the concept. Now in today's class, I am going to talk on polar curves, angle between the polar curves and condition for orthogonality, again few problems based on this concept. Now take a look at this figure. As I explained you already about the polar coordinates, let me revise you briefly. In polar coordinate system, the origin is called as a pole. Initial line is called, x-axis is called the initial line. P be any point on the pole. The line joining P be any point on the plane. The line joining the pole and P is called as the radius vector. Okay. Theta is the tangential angle. Now here we have two polar curves. One is R1 is equal to f of theta 1 and R2 is equal to f of theta 2. I have drawn two polar curves at the point P intersecting each other. Okay. So we have two tangents drawn to these two polar curves. The first tangent is PA drawn to the first polar curve R1 is equal to f of theta 1. And phi 1 is the angle between the radius vector and tangent drawn to the first polar curve. So this is phi 1. Okay. Next, what is phi 2 here? Phi 2 is the angle between the radius vector and tangent drawn to the second polar curve, that is PB. Okay. So this angle is phi 2. Now, what could be the angle of intersection of these two polar curves? How will you represent it? So, the acute angle of intersection of the polar curves is always equal to modulus of phi 2 minus phi 1. Why we take modulus? Because we prefer to keep the angle of intersection of two polar curves as a positive quantity. So, I will take modulus. Now, next is, suppose this formula is used to find out angle of intersection of two polar curves. Provided phi 1 and phi 2 must be got explicitly. Okay. If you are able to find out what is the value of phi 1 and what is the value of phi 2 from the given problem, then you can substitute the value of phi 2 and phi 1, take the difference and take the modulus of it. That gives the acute angle of intersection of two polar curves. Now, if it is not possible to find phi 1 and phi 2 explicitly, okay, then in such a case we will use the formula tan of phi 1 minus phi 2 is equal to tan phi 1 minus tan phi 2 divided by 1 plus tan phi 1 tan phi 2. This formula is used if phi 1 and phi 2 cannot be found explicitly. Okay. So remember these two formula to find out angle of intersection of two polar curves. One is this formula and the second one is modulus of phi 2 minus phi 1. These two are the formula used to find out the angle of intersection of two polar curves. Got it? Next we will come to the next condition. What is a condition for orthogonality? What do you mean by orthogonality? As I told you, these two curves are intersecting each other. Okay. If they are intersecting at an angle pi by 2, then we say that the two polar curves are intersecting orthogonally. So the condition is if modulus of phi 2 minus phi 1 is equal to pi by 2, then we say that two curves intersect orthogonally. Okay. So for condition for orthogonality, one more condition is there. This is one condition to show the two curves are intersecting orthogonal. The next one more condition will derive if phi 2 minus phi 1 is equal to pi by 2. If they are intersecting orthogonally, then phi 2 can be taken as pi by 2 plus phi 1. Correct? Now if I apply tan phi 2 is equal to tan of pi by 2 plus phi 1. tan of 90 plus phi 1 is minus cot phi 1. Correct? So I will get tan phi 2 is equal to minus cot phi 1. Cot can be taken as 1 by tan. So I will take 1 by tan phi 1. So let me cross multiply this. So tan phi 1 into tan phi 2 is equal to minus 1. This is the second condition for orthogonality. So this is the alternative condition for the orthogonality of two polar curves. So let me write all the formula here so that you will not be in a confusion state. The third formula is, if the two curves, polar curves, are intersecting orthogonally, then phi 2 minus phi 1 modulus of it is equal to pi by 2, or I can use the formula tan phi 1 into tan phi 2 is equal to minus 1. These two are the conditions for orthogonality. So the first two formulae are used to find out the angle of intersection of two polar curves. The next two formula gives you whether they are intersecting orthogonally or not. Okay, have you followed? Now using all these formula, next let me move on to few problems on polar curves. Okay, now look at this problem. Find the angle of intersection of polar curve. We have two polar curves. R square sin 2 theta is equal to 4 and r square is equal to 16 sin 2 theta. Now how to work out this? We know already angle of intersection of two polar curves is modulus of phi 2 minus phi 1. That means I have to check whether I can find out phi 2 and phi 1 explicitly. If it is possible, then use this formula and calculate the angle of intersection. So let me try finding out phi 1 first. So take a look at the first curve. R square sin 2 theta is equal to 4. As you know already, to find out phi 1, in the last video I had explained you, we have to take log on both the sides for a given curve. I have taken log of r square sin 2 theta is equal to log 4. Now this is log of a into b. This can be written as log r square plus log of sin 2 theta. Correct? Log a plus log b. Log of r square can be written as 2 log r using the logarithmic property, plus log of sin 2 theta is equal to log 4. What I will do now? I will differentiate with respect to theta on both the sides. I will keep 2 as it is. Differentiation of log r is 1 by r. R with respect to theta you are differentiating, so I will get dr by d theta. Okay. Next, differentiation of log of sin 2 theta is 1 by sin 2 theta. Sin 2 theta if you differentiate again, cos 2 theta. 2 theta again I have to differentiate, it gives 2. Okay. On this side you have log 4, it is a constant term, the differentiation is 0. Okay. So 2 as it is, 1 by r dr by d theta is always cot phi 1. Look at, go through the previous video, you will get this derivation. 1 by r dr by d theta is cot phi 1 and cos by sin is cot. I have taken this term on this side, on the other side. So it becomes minus 2 cot 2 theta. 2 and 2 goes, cot phi 1 is equal to cot of minus 2 theta. So phi 1 is equal to minus 2 theta. So I got phi 1 explicitly, right? Now look at the second curve. R square is equal to 16 sin 2 theta. So r square is equal to 16 sin 2 theta. I'll follow the same procedure. Take log on both the sides. Log of r square is equal to log of 16 sin 2 theta. So 2 log r is equal to log of a into b is log a plus log of sin 2 theta. Now differentiating this 2 as it is, log r differentiation is 1 by r dr by d theta. Log of 16 is constant, differentiation is 0. Log of sin 2 theta's differentiation is 1 by sin 2 theta. Sin 2 theta again if you differentiate it gives cos 2 theta. 2 theta again if you differentiate gives 2. So cot phi 2, let me take this as, is equal to cot 2 theta. Therefore phi 2 is equal to 2 theta. So I got phi 1 and phi 2 values. Now I will substitute into the formula mod of phi 2 minus phi 1. Correct? So phi 2 is 2 theta minus phi 1 as we derived already is minus 2 theta. Substitute here. So it becomes 4 theta. Therefore angle of intersection of these two polar curves is 4 theta. Okay. Now we'll move on to the next problem. Look at this problem. Find the angle of intersection of the curve r is equal to a log theta and r is equal to a by log theta. Okay. Now take first curve r is equal to a log theta. Let me find out phi 1 from this to this curve. Take log on both the sides. Log r is equal to log of a log theta. Correct? To this I have applied log. So I will get log a plus log of log theta. Right? Now I will differentiate with respect to theta. 1 by r dr by d theta. Log a is constant. Differentiation is 0. Now look at this function. It is little confusing. The differentiation of log theta. Right? If you have log x, differentiation is 1 by x. X again you differentiate, right? The same thing. Log of log theta's differentiation is 1 by log theta. Log theta again if you differentiate, it is 1 by theta. Okay. So I'll get cot phi 1 is equal to 1 by theta log theta. Now you can see here I cannot find out phi 1 from this expression. As I told you, if it is possible to find out phi 1 and phi 2 explicitly, then I can use the formula directly. Otherwise, I have to express this in terms of tan. Okay. So what is tan phi 1 from this? The reciprocal of cot. So tan phi 1 will be the reciprocal of this is theta log theta. Okay, 1 by theta log theta becomes theta log theta. That will be tan phi 1. Similarly, the next curve r is equal to a by log theta I have. So I will consider this curve r is equal to a by log theta. Take log on both the sides again. Okay, and differentiate with respect to theta. Log a differentiation is 0. Again the differentiation of this term 1 by log theta. Log theta again if you differentiate 1 by theta. So it gives cot phi 2 minus theta log theta. Again phi 2, it is not possible to extract phi 2 from this. So I will find out tan of phi 2. The reciprocal of this again. It is minus theta log theta. So I have tan phi 1 as theta log theta, tan phi 2 as minus theta log theta. Then how will you find out the angle of intersection of these two polar curves? I have to use this formula as I explained you already. So look at this formula. Tan of phi 1 minus phi 2 is tan phi 1 minus tan phi 2 divided by 1 plus tan phi 1 tan phi 2. So all the values I will substitute here. What is tan phi 2 that I have got already? Theta log theta. Tan phi 2 minus theta log theta. All the values I will substitute. Okay. So theta log theta minus into minus plus theta log theta divided by plus into minus. Here it becomes minus. Theta log theta into theta log theta is theta log theta whole square. This is tan of phi 2 minus phi 1. Okay. So I will check whether I can simplify this further. Yes, it is possible to simplify, right? So I can add these two terms. Theta log theta plus theta log theta becomes 2 theta log theta. Look at here. 2 theta log theta divided by 1 minus theta log theta whole square. This is tan of phi 1 minus phi 2. But using this expression, I cannot find out the angle between the two polar curves easily because we have unknown quantities. What is theta here? I don't know what is theta. So I have to find out what is theta. Find out what is theta and substitute back into this equation. Call this as equation 3. If you substitute back into this equation, that gives the angle of intersection of two polar curves. Then how will you find out theta? What we will do now, they have given the equation of the curves, these two equations. Actually, we are finding out the angle of intersection of these two polar curves. R is equal to A log theta, R is equal to A by log theta. Now, these two curves I will consider. So, consider these two curves. You can see here, I can equate RHS of these two curves because LHS is same. So, I will equate the RHS. I will get A log theta is equal to A by log theta. A and A I can cancel. I can cross multiply log theta and log theta. It gives log theta whole square is equal to 1. So what is log theta? Is equal to 1 because square root of 1 is 1. So what is theta? Actually we are taking log means base E will be there here. So I will get theta is equal to E power 1 by taking antilog, right? E power 1. So theta value is E. So I got what is theta. What I will do now? I will substitute this theta is equal to E back into equation 3. Okay. So I will get tan of phi 1 minus phi 2 is equal to, look at equation 3. 2 theta log theta you have. Theta value is E. Therefore 2E log E divided by 1 minus E log E whole square. Okay. So tan of phi 1 minus phi 2 is this expression. But what is log E value? Log E, base E is always 1. So this becomes 1. The value of this becomes 1. So if you substitute, here also log E value is 1. So I'll get 2E divided by 1 minus E square. Or phi 1 minus phi 2 is equal to tan inverse of 2E divided by 1 minus E square. This gives us the angle between or angle of intersection of the polar curves R is equal to A log theta and R is equal to A by log theta. Okay. Now move on to, I think we'll move on to next problem, a simple problem. We'll take up the concept of orthogonality now. Okay. So far we have seen two problems on finding the angle of intersection of two polar curves. Now take a look at one problem. How to show that these two curves r power n is equal to a power n cos n theta, r power n is equal to b power n sin n theta. These two are the curves intersecting orthogonally. Show that the curves intersecting orthogonally. Okay. So let me work out this problem. We have the curve r power n is equal to a power n cos n theta. Again the same procedure. I will apply log on both the sides. Okay. Log of a power n plus log of cos n theta it becomes. Okay. So this can be written as n log r, as you know already. This is n log a using the logarithmic property plus log of cos n theta. Now I will differentiate with respect to theta. N as it is, log r differentiation is 1 by r dr by d theta. N log a is constant, differentiation is 0. Log of cos n theta is 1 by cos n theta. Again I have to differentiate cos n theta, it becomes minus sin n theta. N theta if you differentiate again, it gives n. So what I will get? N 1 by r dr by d theta is cot phi 1 minus n sin by cos is tan n theta. N and n you can cancel. Cot phi 1 is equal to, since you have cot on this side, let me express minus tan also in terms of cot. It is cot of pi by 2 plus n theta. All these formula I have given you in the video video 1 of my teaching. Please subscribe this channel to have more, to understand more and more concept. So what is phi 1? Phi 1 is pi by 2 plus n theta. I got phi 1. Similarly, I will consider one more curve r power n is equal to b power n sin n theta. Consider one more curve r power n is equal to b power n sin n theta. I will follow the same procedure. Again, if you take log on both the sides, it is n log r, n log b plus log of sin n theta, right? Differentiate with respect to theta, 1 by r dr by d theta, n log b is 0, differentiation is 0, 1 by sin n theta I will get, sin n theta if you differentiate I will get cos n theta again if you differentiate you will get n. I can cancel n and n, so this is cot phi 2 is equal to cos by sin is cot n theta. So what is phi 2? Phi 2 is equal to n theta. You can see here we got phi 1 and phi 2 explicitly. Both the values I got directly. So to prove these two curves are intersecting orthogonally, what is the condition for orthogonality is modulus of phi 1 minus phi 2. So phi 2 is n theta minus what is phi 1 I got? Pi by 2 plus n theta. I will substitute here pi by 2 plus n theta. Right? So n theta minus pi by 2 plus into minus n theta. Plus n theta and minus n theta goes, I will get pi by 2. So I have proved that these two polar curves are intersecting orthogonally. So thank you very much for listening. If you people are finding my teaching easy, then please subscribe, like and share my videos. Thank you. Bye.